Imagine holding the most powerful substance in the universe in your hand. A teaspoon that could destroy a city instantly. Sounds impossible? It isn't. This is antimatter. In the next few minutes, we'll explore what antimatter really is, why it's the most dangerous substance known to science, how it's made and stored, and why it could either power the future, or end it. Prepare yourself, this is Science on the Edge. First of all, let's answer the main question, what is antimatter? Everything in the universe is made of matter, protons, neutrons, electrons. But every particle has a twin, an antiparticle with the same mass but opposite charge. Electrons have positrons. Protons have antiprotons. When matter meets antimatter, they annihilate instantly, releasing pure energy according to Einstein's famous equation, E=mc². That means even a tiny amount of antimatter produces a colossal amount of energy. 1 gram? Enough to rival the most destructive bombs ever made. Now, here's where things get really interesting. How powerful is antimatter? Let's put it in perspective. 1 gram of antimatter reacting with 1 gram of matter produces about 21 kilotons of TNT, the same as the atomic bomb dropped on Hiroshima. Now imagine holding a teaspoon in your hand. The energy stored in that tiny volume could level a city instantly. Even a microgram, a millionth of a gram, packs more punch than all the fuel in a car. That's why scientists call antimatter the most energy-dense substance in the universe. It's unbelievable, right? But that discovery led to an even bigger question. How do we make antimatter? Creating antimatter is extraordinarily difficult. Particle accelerators, like those at CERN, smash particles together at nearly the speed of light. From these collisions, tiny amounts of antiprotons and positrons are produced, only nanograms per year. The cost? Astronomical. And that's just production. Storing antimatter is even trickier. It can't touch normal matter, or it will explode instantly. Scientists trap charged antiparticles in penning traps, using magnetic and electric fields to keep them floating safely in a vacuum. Neutral antimatter, like antihydrogen, is even harder to contain because it doesn't respond to electric fields the same way. Every particle we trap is an achievement in precision physics. In our next part, let's talk about the potential uses of antimatter. Why even bother with such a dangerous substance? Antimatter has incredible potential. In the distant future, it could be used as a super-efficient fuel for interstellar spacecraft, producing enormous thrust from a tiny mass. Scientists imagine ships powered by antimatter traveling far beyond our solar system. It could also revolutionize energy production, providing extremely compact, high-output energy sources. But the risks are immense. One tiny leak and you'd have a catastrophic explosion. Do you know the dangers and ethical concerns of antimatter? Let's talk about it now. Antimatter is not just a scientific curiosity, it's a potential doomsday material. If weaponized, even micrograms could obliterate cities. Fortunately, current production is tiny and tightly controlled by physics labs. But as technology advances, the ethical questions grow. Who controls antimatter? How do we prevent accidents or misuse? Responsible research and international agreements will be essential to ensure antimatter is studied safely, not weaponized. Okay. Now in our last section, let's see why we study antimatter. Despite its risks, antimatter is scientifically invaluable. Studying it helps us answer some of the biggest mysteries of the universe. Why is there more matter than antimatter? What happened in the first moments after the Big Bang? Every particle trapped brings us closer to understanding the cosmos. Antimatter is a key to unlocking the fundamental secrets of our universe, and that's what makes it both terrifying and fascinating. As we mentioned in our video so far, antimatter is deadly, powerful, and utterly mysterious. Humanity may one day harness its energy, or it may remain a ghost on the edge of our reach. Well, with that part, we are going to end the video that we brought you today. With the promise of bringing you another informative video like this one, thanking all of you very much for sticking with us until the end of the video. If you like our videos, please don't forget to subscribe to the Secret Diary International channel. Have a good day everyone.